So for chapter 9, after the intro that we've done, we're going to tackle something called completing the square. Now, completing the square will come up again in Algebra 2. It is a procedure that some students find difficult and others do not. It's a procedure that is used for a number of things. So first in this overview video, I want to show you kind of why we do this and where are the benefits. And then in a couple of follow-on videos, we'll give you very good procedures to follow. Also, I want to mention that the book, chapter 9.5, is a decent read looking at the examples. The examples would be a good thing to go over to find some procedural stuff in addition to my examples that I'm giving you. So let me share my screen with you, give you some ideas here of what we're doing. So chapter 9.5, completing the square. Now, why would we do this? This is a sheet from a previous video. We talked about kind of moving between these three forms, between standard form and vertex form and factored form. Chapter 8 was all about changing between standard form and factored form, standard form and factored form. And I keep saying that that is a huge, huge skill. But what about when this isn't factorable? Then you might want to go to a different form. Vertex form is something that you can always go to. And in order to do that, we talked about getting from vertex form to standard form is easier, just multiplying. But to go from standard form to vertex form, you need to complete the square. So that's one of the reasons to deal with completing the square. Another thing is, what if you have an equation like this, 0 equals x squared minus 14 plus 16? Well, it appears that you would want to factor this. But if you should go and try to factor it, the factors of 16 will never come up as the sum of negative 14. So you can't factor this equation, nor can you factor the equation if you're looking to try to graph it. Now, if you were trying to graph it, maybe you would have some other alternatives other than completing the square. But a quadratic trinomial in this form, because it doesn't factor, we need to be able to do something else with it. All right, so let's take a look at a couple of equations that you know what to do. If we want to change from standard form to vertex form, remember vertex form is like y equals a times x minus h squared plus k, or maybe minus k on the other side. It doesn't really matter where we put it. Something like that, where hk we can find the vertex of. That's what we've been talking about in the last few videos. So if we wanted to do something with this particular nice trinomial, this is a perfect square trinomial. Remember from chapter 8, we talked about perfect square trinomials where the 3, that's a perfect square factor of 9, also creates the o and the I to make the negative 6. So in vertex form, you actually know how to do this one, x minus 3 squared. That is in vertex form. It doesn't have a k value, or its k value is 0. It doesn't have an a value, or its a value is 1, but it's still vertex form. So if we have a perfect square trinomial, then getting to vertex form is easy. So in the second problem, could we create a perfect square trinomial? Like, what would we really want this number to be? Let's see. If we had this situation, notice the negative 3 creates the negative 6 because it's half of it. We would kind of hope that we would have x plus 4 as our item that we're squaring, as our binomial, linear binomial that we're squaring. So if we had this situation, we would have a plus 16 here in our last position. Now, if we had a plus 16, we could do just what we did in the first one. But if we didn't have a plus 16, and we just started off with this particular equation, if we add 16 to one side, we'd probably better add 16 to the other side to keep it balanced. All right. So in doing so, we wind up with a plus 16 over here. So that notice that this expression is equal to this expression. Right? And originally, y was only equal to x squared plus 8x. So we need to, in order to make, let's see, another color, in order to make this expression equal to this expression, the y's only were that part of it, so we need to add 16 to both sides. So that's one way to do it. We're going to go over a very clear procedure of how to do that. Here's another one that's going to get a little messier. This is why you're going to say, oh, I need a procedure. So let's see. We have a 16 here. So let's see. We would hope to have y equals, let's see, x minus 7 squared. That's going to create the negative 14 that we would need as a perfect square. But x minus 7 squared would actually create, instead of a 16, it would create a 49, wouldn't it? Well, in order to get to 49, we need to add 33, I think 33 to that. If we add 33 here, we got to add 33 here. So that means we have to add 33 here. Now, this looks really messy. I'm not expecting you to follow what's going on here. But if you take that statement, the original statement we had, and this new statement, and put them both into Desmos, I think you'll find that they are exactly the same graph, meaning this in vertex form, and this is in vertex form, is equivalent to this in standard form. And converting between the two is kind of the skill we're looking to build for a variety of reasons. So that's a little bit of an overview. I'll teach you a good procedure for doing this on the next few videos. Probably take 2 or 3 or 4 examples of that, because this is a procedure that people have a hard time picking up on. The problems could get even more difficult than this. They could go to something like y equals 3x squared plus 18x minus 15. Well, how are we going to do a perfect square trinomial of that when there's a 3 there? That's screwy. Probably going to have to get the 3 out here. So we're going to have to do some factoring here to do something like maybe 6x, and then we're going to have a procedure for that. So all of those details are going to come out in the next few videos. Now, I would recommend that you read page 577, which page 577 is in chapter 9.5. It's the book's examples of completing the square. So I would do that, and then take a look at my follow-on videos where I'll do problems different from what's in the book, but we'll definitely do some factoring, completing the square to create vertex form, and also to solve equations. So I'll go over kind of how to do both of these, solving equations and the graphing portion. Okay, good luck with this section.